Hello guys, I hope you are good. Also good. So today we'll be discussing integrals involving inverse hyperbolic functions. So this is similar to integrals involving inverse trigonometric functions. I mean, like the procedure, the way we solve it is the same. So yeah, let's see how we're gonna do it since it's hyperbolic function, but the explanation is the same. But yeah, so we've got few formulas here. So let me also just remind you that integration is just us going back to what was differentiated before. So you remember in differentiation we'll be given something like this. For example, hyperbolic inverse hyperbolic sine of f of x. So and then if we differentiate it, then we're going to use this formula and say f prime of x divided by the square root of f of x squared plus 1, so that we get our answer. So in integration, it means in integration now we'll be given this right hand side, and then Tina, we should find this one. So that's what we'll be doing basically. So we'll be given this format, and then Tina will then conclude that it is a hyperbolic sine inverse of f of x. So yeah, so everything there, the same explanation applies to all of these other ones. You understand? Cosec inverse, sec inverse, cot inverse, cos inverse, hyperbolic tan inverse, of course. So the very same explanation applies to all of them. We'll be given these right hand sides, and then Tina will conclude that this is this. But before you make any conclusion, you should first make sure that on your numerator, you have the derivative of whatever that is squared here. You understand? So I'm going to do examples and an activity there down there to quickly show you how it's done. So stay tuned. So in most cases, you'll be dealing with questions whereby your a here, the number that is here, is not equivalent to 1. If you have noticed here, our a here is equivalent to 1 because this is the same as 1 squared, so meaning that our a is 1. So what in most questions that we'll be doing, we'll be dealing with questions whereby our a is not equivalent to 1. So meaning that when we conclude, we have to say, if it's this format, then we have to say it's hyperbolic sine inverse of f of x over a. So yeah, and then the very same explanation applies to all of these other formulas. So that's what we'll be doing. So yeah, stay tuned. So let's start with this one, this example, and then let's see what damage we can do to it. So okay, now we need to first rewrite it first before, so that we can see what is our f of x and what's our a, stuff like that. So we have to write it in that format of a squared f of x squared. You understand? So that we can see what is the f of prime, what. So let's first rewrite this in a nice way. So this one is going to be as follows. We've got 1 on our numerator. We've got square root of, so 25 is the same as 5 squared. And then 9x squared is the same as 3x to the power of 2. And then we've got our dx there. So when we check this format of whereby in the denominator we've got square root of a squared plus f of x squared, is this first one. And you can see, right, we've got f of x squared plus a squared. So meaning that the only thing that so now that means we know that already. So that means we know already that we're dealing with hyperbolic sine inverse. So now we just need to make sure that in our equation we've got the derivative of whatever that is squared there. You understand? So let's go back to our equation quickly. So the thing that is squared here, it's 3x. So meaning that on our numerator, before we make any conclusion that this is hyperbolic sine inverse, we need to first make sure that here on our numerator we have the derivative of the thing that is squared here. You understand? So when we differentiate 3x with respect to x, we get 3, and we can see we have 1 there. So, and we are allowed to manipulate numbers or constants, so that means here we can just write our 3. And then since in our question we were not given this 3, it was 1 initially, so meaning that if I just write this 3, then I've changed the question, you know, I'm now answering my own question. So meaning that I shouldn't suppose, I'm not supposed to do that, you know. So I must cancel out this 3 by multiplying by 1 over 3 outside the integral, so that this 3 that I wrote and this 3 can cancel out, and I go back to the very same question that I was given. But I'm not going to cancel out because I want to make use of having f prime of x and f of x here, or having the derivative of what's here on my numerator, you understand? So since 3 is the derivative of 3x, then now I can then conclude that if I have f prime of x on my numerator, and here I have the square root of f of x squared plus a squared, which is the same as what I have here. So meaning that I can now make a conclusion now that the answer to this integral is the same as hyperbolic sine inverse of what? Of f of x over a, my a being 5, then plus c. Of course, I shouldn't forget that whatever that's outside the integral should always go with me to the answer, you know. So that means that here I'm going to write 1 over 3, and then ta-da, that's your answer. So the most important thing that I can say here is just to first figure out which format does that question that we are dealing with belongs to when it comes to the formulas that we have here. So the most important thing is the denominator. You have to take note of the denominator. Of course, in your test you must have memorized all of these formulas, so there is a little bit of pattern here. Let me quickly show you the pattern behind these formulas. So it's more like you need to remember the reciprocals. So you know that sine goes together with what? With cosec, right? Sine goes together with cosec, and then what? Cos goes together with secant, and then tan goes together with cotangent. So how do they work? So let's start with the first one. So you see, I said sine goes together with cosec. Like you can cram that in the form of what? Reciprocals. That sine goes together with cosec in the form of reciprocal. So they work in that way. So what happens is that sine has is gonna the denominator of sine and that one of cosec is gonna be the same inside. However, you keep the middle sign the same, and then you just swap the two to the left and right. You keep the middle sign the same, and then you swap f of x squared and a squared. You swap them. That means this one will go there and this other one will go there. You understand? You see how it's like? Look at this one and look at this one. So, and then of course you shouldn't forget to put f of x inside the absolute value there, and then also to remember that your answer for that one of cosec will have negative 1 over a, and then yeah, then the same explanation goes to the other ones. The one of cos goes together with the one of secant. So what you do, you keep the sign the same, and then you swap the two. Then you make sure that outside there is f of x, and then f prime of x there on top, and then just like that. And then yeah, tan and this one are the same. You keep the sign the same, but then you swap when it comes to that other one. You swap the a squared and that one. So that's the pattern behind. I mean, like for you to quickly cram them, because you're supposed to memorize them for your tests. So that's how you're gonna memorize them. Anyway, let's quickly check some other examples that we can discuss to make sure that you end up mastering this chapter, since it's an easy one as well. So let's go. So another thing that I would like to tell you that is that you're not always gonna be given direct ones, or basically in your test it's gonna be rare for you to be given it directly. I mean, like given the inverse, integrating the inverse of the hyperbolic functions directly. Sometimes it's gonna come in a way of you having to use what is this, general power rule, general log rule, and so on and so on. So you just need to be very careful. So just like this one, when we check this one, there is no way that we can say one of the inverses from these formulas was we cannot really conclude that it's one of the inverses here because of, look at it. Remember, whatever that is squared there should be on our numerator, we should have the derivative of whatever that is squared here. So when we check here, of course, this format of a square root of 1 plus x squared is that one of sine inverse, but it's failing to be the integral of hyperbolic sine inverse because of what? Because of, we know that whatever that is squared here, we should see the derivative of it on our numerator. So when we check our numerator, there is no way that the hyperbolic sine inverse is the derivative of x, you know. So that means that tells you that now you have to think about other rules that we use: general power rule, general log rule, and so on and so on. Of course, you have to think of general power rule and general log rule at first before you think of the other rules. Makes sense, right? So like I've explained, this one already failed to be one of the inverses there, so we can't directly do that. So we check now that can I make one f of x and the other one f prime of x? So when we check, of course, when we differentiate, if we were to make the denominator to be our f of x, then the numerator cannot be our f prime of x. But instead, now if we make our numerator to be our f of x, then this one can be f prime of x. I'm doing this so that I'm testing the use of general power rule. So whenever you let something to be f of x and the other one be f prime of x, you are trying to see if general power rule or general log rule can be used. You understand? So that's what I'm trying to find out. So now I can see that no, if I make this numerator, which is my hyperbolic sine inverse of x, to be my f of x, then definitely 1 over this. So let me also first rewrite this in a nice way so that my arguments can make sense. So here I'm going to have my e, my 1, and then I have my 1 over square root of 1 plus x squared multiplied by what? Multiplied by sine inverse of x dx. So what's happening here is that I say that, okay, I hope you all can see that this thing and this thing that I wrote here is the same thing. I just took out sine inverse from the numerator and I put it on the side there. I hope that makes sense to you as well, right? So this format makes it clear that if I make this f of x, then this is gonna be my f prime of x. So that means I can put this in brackets so that it can be nicely so also for us to see our n there. So that's what's gonna happen there. So here it is. So I've got my hyperbolic sine inverse to the power 1 and my n being 1. So if I let this to be my f of x, remember the formula for hyperbolic sine inverse is, let me go back, it's this first one. You know, so when we differentiate this one, if here it's x, then that means here we're going to have the derivative of x. So the derivative of x definitely is going to be 1, and then here we're going to have x squared plus 1. So meaning that when we differentiate inverse hyperbolic sine, then we're gonna have 1 over square root of x squared plus 1, which is exactly what we have here. So meaning that this is f of x and this is f prime of x. And then general power rule states that if you have f of x to the power of n and your n is not equivalent to minus 1, then you can then conclude that the answer for that integral is just your f of x to the power n plus 1 all divided by n plus 1 then plus c. Then tada, you got your answer. So that's basically what I'm gonna do there as well. Makes sense, right? Yeah, it should make some sense. So this is going to be just inverse hyperbolic sine of x all to the power of 1 plus 1. So 1 plus 1 is going to be 2 divided by 2. And then, of course, this one has the limits. Then I'm going to put the limits, my e and 1. So the most important thing that I wanted to show you is just how to integrate. I didn't want to substitute the limits. So for this case, let's just stop here. I just wanted to show you that one. So you have to be in a lookout for that type of questions as well. All right. Yeah. So now let's quickly check our activity 8. So I believe now you have a little bit of confidence when it comes to this thing. So please take out a piece of paper and a pen and a calculator, and then you start practicing with me. That way you will quickly grab these concepts. So yeah, let's go. Feel free to pause the video, work it out by yourself there, and then resume later to check the memo. So yeah, I wish you luck. Let's go. So at activity 8, our first question being number 1, whereby we should integrate the following. 1.1, integrate b over a squared minus x squared dx. So we're integrating with respect to x, meaning that whatever letter that is not x, it's a constant. We treat it as a constant. That means our b, our a are both constants. In simple terms, they are numbers. You can treat it like a number. That's what I'm trying to say. Because of we're integrating with respect to x. That means our main focus has to be this one of x. So what can we do? So I can say maybe I can the first step to these things of integrating inverses is to rewrite your equation in a nice way first. So here we're given b, so I'm going to take my b outside the integral and then be left with 1. And then here I have my a squared minus what? Minus x squared dx. So what's happening here is that, remember, on all of those formulas, on the numerator, you should make sure that you have the derivative of whatever that is squared here. So when we check, the thing that is squared is x. So what is the derivative of x is 1, the one that we already have here. So I don't have to cook anything here. I already have my f prime of x. So meaning that now I can just make a conclusion that this format of a squared minus x squared is this one. So let me just quickly go back to the formulas. I won't be going back now and forth. So we have what? We've got a squared minus x squared. So is this one of tan inverse? You know, is this one of tan inverse? So that means my answer now I have to say it's 1 over a tan inverse of wara, and then make a conclusion just like that. So that's what will be going. That's what will be happening now. So I've already said that my answer will have 1 over a multiplied by the hyperbolic tan inverse of what? Of f of x. My f of x being x for this case is just x upon what? Upon a, and then plus c. Of course, I should always remember that whatever that's outside the integral should go with me to the answer, meaning that this b, I'm going to take it with me to the answer. So I'm just going to write the b here, or I can just change this one to be my b. And then, ta-da, you have your answer. So, yeah. And then we've got another question here. Remember, you are pausing the video to work it out first on your own and then resume later to check the memo. So I just want to emphasize something on this question. This question says integrate e to the power hyperbolic sine inverse of 2x all divided by the square root of 4x squared plus ln of e dx. So previously on my other videos, we have been solving a lot of integral questions involving e to the power something or involving an exponential function. So you have to be aware that immediately when you have an exponential function like this, you should always remember that this question that I'm dealing with, it's a question where that involves me integrating exponential functions. So of course you should think of inverses as well, but like the main thing that you are doing there is integrating an exponential function. So you must cram this format, you must memorize this format. There are a lot of questions for this that we have done, assuming that we might still be dealing with the same questions. They like this format in these questions that I'm dealing with. So yeah. So what we need to do first as well for this question is just to rewrite it first in a nice way. So what I'm gonna do here is to rewrite the question in a nice way. Why am I rewriting the question in a nice way? Is to see that, okay, this format of inverse is that one of cos or what. So if you have written things in a nice way, then it's easier then for you to be able to recognize that, okay, yeah, I'm dealing with this guy. So yeah, that's what I'm trying to find out as well. So let's rewrite it first in a nice way. So what I'm gonna do here is to do this. So I'm gonna have my 1 over. So I'm gonna change okay, what's the first step? Oh, I'm gonna take the e out. Okay, so let me not complicate things. 4 plus ln of e multiplied by e to the power hyperbolic sine inverse of 2x dx. So what's happening here is that we should remember that now, since we are dealing with an exponential, the integration of an exponential function, we should remember that whenever we're integrating an exponential function, more especially this one of e, then we need to check before we make any conclusion that do we have the derivative of the exponent of that exponential function. You understand? So when we check the exponent there, it's hyperbolic sine inverse of 2x. So we check that is this exponential function multiplied by the derivative of the exponent before we make any conclusion. So that means we need to make sure that this one is the derivative of the exponent. So when we differentiate this one, the hyperbolic sine inverse of x, we should have the derivative of it on the numerator divided by what? By the square root of the argument squared plus the base. You understand? So what are we going to do here? We are going to plus 1 for that case. So remember, ln of e is 1, so it has to be plus 1. So ln of e shouldn't scare you. It's a 1, guys, so it shouldn't scare you. So this question, it's more like we are almost done with it. So let's see, what can we do to this question? So what are we going to do? We are going to make sure now we rewrite this question in a way that y'all can see that it is indeed the derivative of the exponent there. So let's rewrite it first. So what I'm gonna do here is to say this one, I put this in a square root, so I write this in a f of x squared manner. So that means I'm gonna write it as 2x to the power of 2. So 2x to the power of 2 is the same as 4x squared, plus I know that my ln of e is the same as 1, right? And then there I already have my e to the power hyperbolic sine inverse of 2x, and then I have cos, I have my dx there. So what am I supposed to do here? So for this part, of course, I have a 1 here. I shouldn't forget that one. So for this part to be fully the derivative of this, I must make sure that on the numerator, I have the derivative of the argument that is squared here. You understand? So when I check the thing that is squared, it's 2x. So what is the derivative of 2x with respect to x is a 2. But when I check my numerator here, I only have 1. And 1 is not the derivative of 2x. So that means I should cook now and make sure that I have the derivative of 2x. So meaning that I'm going to cancel out this 1 and write my 2. But then I didn't have this 2. So what am I doing to this question? It means now I changed the question. Now I'm answering my own question. So it's not allowed, guys. You might even get arrested for you to be making your own questions there in the test. So please don't do it. So now that I've written my 2, I must cancel it out because of it's not allowed to just write something there and then you understand. So let's cancel out that 2 by writing 1 over 2 outside the integral. So that 2 and 2, they cancel out. And then you still have the same question that you were dealing with. All right, but then I'm not going to cancel out because I'm trying to answer this question. So I'm going to make use of 2 being here, you understand? And then I leave the 1 over 2 outside the integral. So when I have the derivative of the exponent and this exponential function here, multiplying each other, then I can then conclude that the thing that was differentiated is just this exponential function. Of course, if you forgot integration of exponential function, then please kindly go back to my previous videos. I've already explained nicely how to integrate exponential functions. So I'm assuming that all of you are cruising because now we are moving forward. So yeah. So that's what I'm gonna do. So remember, now we're writing the answer. So whatever that's outside the integral should always go with you to the answer, meaning that this 1/2, I'm gonna take it with me to the answer, and then I also give the answer for this. I've already given you that if I have the derivative and an exponential function, then I can then conclude that it is just that exponential function that was differentiated. So integral of 2x, anyway now, 2x plus c, then tada, you have the answer there. So I hope you got it. It was an easy one. All right, so let's do this one. So all right, let's check. So now we've got the integral of 1 divided by the hyperbolic inverse of cos of x multiplied by the square root of x squared minus 1. So when we check this case, does it fall under any of the formulas that we know? No, because we know that in our formulas, if this one wanted to be maybe cosec or hyperbolic secant, then x was supposed to be x only here, but instead we have got hyperbolic cos inverse. So meaning that I have to think about general power rule or general log rule for this case. So that means we are going to check now. If I let square root of x squared minus 1 to be my f of x, can then be hyperbolic cos inverse be my f prime of x? Definitely a no. But then instead, if I make hyperbolic cos inverse to be my f of x, then square root of x squared minus 1, of course, divided upon 1 is definitely going to be my f prime of x. So meaning that I have to also rewrite this first before I make any conclusions, so that you're also convinced with what I'm doing. So the first thing that you're supposed to do now is just to rewrite it in a nice way. So look at this nice way. Look at it and you'll tell me, isn't it nice? Isn't it? So I've got my x squared minus 1, yeah, and then I've got my hyperbolic cos inverse of what? Of x. Of course, I shouldn't forget my dx. So what did I do now? What did this guy do? Because now he's doing things now. So what did I do? So I took out square root of x squared minus 1. I took it up. So when you take it up, it goes with that 1 that is here, because initially we have like a 1 here. So it goes with that 1. It lifts that 1 up. Yeah, but yeah, I don't know. It's just my way of making it make sense. But I believe it makes sense to you, maybe in another way. But yeah, I hope you understand that this thing that is given to us is the same as this one, right? So that's what I did. So now we say that our this one is going to be our f of x. So when we have our f of x on our numerator, on our denominator, I mean, and that f of x having an n of 1, then we use general log rule. Of course, if you forgot, you are welcome to go back to my previous videos. I've explained general log rule nicely, so feel free to go back and revise if now you have forgotten or you're starting to get chopped. It shouldn't chop you. So that's what's going to happen now. So if this is my f of x and that's my f prime of x, then I can then make a conclusion, because general power rule states, the general log rule states that you just take your f of x and then you put it inside the log. So that's just going to be ln of what? Ln of f of x. So ln of f of x. Our f of x, we're saying it's our hyperbolic cos. So this is going to be hyperbolic cos inverse of x. Then you close. Then you say plus c. Ta-da! You have your answer. So that's just it. Makes sense, right? Make sense. Yeah, it does. It does. It does. I can hear you saying it as a yeah. Indeed, it does, eh? You're preaching, man. Yeah. Anyway, let's quickly check this one. I hope you are getting the other ones as well, because they are very, very easy. In Tonga, they would say Swilahlini. So Swilahlini, but Swilahlini sister, so I'm Chavis. So anyway, let's continue. Swilahle blind. We've got this one. We've got this question now. Integrate hyperbolic cos of x divided by the square root of hyperbolic sine of x all squared minus 9 and then dx. So now we check. Can this one fall under any of the formulas that we know? Can this format fall under any of the formulas that we know? So that we can use one of the inverses there. If it's tan inverse, we use tan inverse, blah blah blah. So we check. So we can see that yeah, it can fit because of we've got something squared minus a squared, and then we've got something on our numerator. But before we make any conclusion, you should also be convinced. So let's first rewrite it in a nice way. You shouldn't just take chances. So rewrite it first in a nice way so that you can also see that indeed it is what you're talking about. So for us to rewrite this one in a nice way, we're gonna leave our hyperbolic cos of x on our numerator the way it was, and then we put our square root. All right, so this is gonna be the square root of what? Of hyperbolic sine inverse of x squared minus what? 3 squared. So what I did there, I just rewrote everything in the form of what squared. If it's f of x, then f of x squared, and then if it's a, then a squared. So 9 is the same as 3 squared. Hyperbolic sine inverse squared of x is the same as opening the bracket and then you put sine inverse hyperbolic sine inside and then you square it, and then I left my hyperbolic cos on the numerator untouched. So that's how it is. So now we check. Okay, this format of for this one to be fully the derivative of one of the inverses, we need to first check that can whatever that's squared here be the derivative of the numerator? Or can the numerator be the derivative? Basically, can the numerator be the derivative of whatever that is squared here? That's what I'm trying to say. So we check. Okay, when we differentiate hyperbolic sine of x, what do we get? We get hyperbolic cos of x, which is exactly what I have on my numerator, meaning that this question, exactly as it satisfies one of the formulas that I have there. So I just then quickly go to my mind or my formulas if I'm given formulas, and then I check this format of having square root of f of x squared minus a squared. Which one is it? Then you go check there. You will find out that, oh, is that one of hyperbolic sine or hyperbolic cos inverse? So then now you can make a conclusion that, all right, my answer to this question is just hyperbolic cos inverse of what? Of f of x. What's your f of x? Is the thing that is squared here, you understand? So then you just write a hyperbolic sine of x, and then you close the bracket and divided by a, sorry. So it's going to be hyperbolic sine of x divided by a, because my a, it's my 3, it's my a, and then I close, I say plus c. Ta-da! You have your answer. So easy like that, easy like that. These ones you just cruise, right? I hope you're getting them there as well, because they are very straight to the point. Even me, who takes chances. I'm getting them. So how about you? What are you? Are you also taking chances, or you really know these things? Myself, I'm just taking chances. Anyway, let's stop my chances and quickly go back to this question and see if they can chop us or we can chop it, because one way or the other, one should get chopped. That's how maths is set, guys. Let's go back to this question. So now in this question, we've got the integral of 1 divided by x 4 minus ln squared of x. Okay, dx, of course. So now I need to check that does it satisfy one of the equations, one of the formulas that we have above there that we discussed. So meaning that for you to check, you must have written your question in a nice way, because the way it's given now, it's not nice. So there is a 1 here. So what I'm gonna do for us to rewrite this in a nice way, I'm gonna take the x up. So already I can see I'm just rewriting this in a way that y'all can see that indeed it satisfies one of the formulas that we have. So I'm gonna take the x up, it's gonna lift that 1 up there, so it's gonna be like this. You understand? So I've taken it up. You see, when you take it up, let's take you're taking it up, you take it up, it lifts that 1 up, you see, so it becomes like this. It's just maths, guys. It's just maths. Of course, we can change this form to 2 squared same time, and then we also change the ln to be inside the brackets like this. And then of course we're gonna also leave the dx the way it was. So this is it. So I believe you all can see that whatever I wrote here is the same as what we were given. You understand? So you shouldn't have a problem with what I wrote here and say, what is this guy writing now? You can't be writing that. You cannot. So look, it is the same, right? It is the same. So this one and this one are the same thing. So now we check that the format of having the denominator being a squared minus f of x squared is which one? So you try to think there, you realize that, oh, this one of having a squared minus f of x squared is the one of hyperbolic tan inverse. So now you check that, okay, for it to be fully that one, then I must make sure that now that I have the derivative of what? I have the derivative of whatever that is squared on my numerator. So I check, okay, the derivative of ln of x with respect to x, what is it? It's just 1 over x, right? So I check, is the numerator the derivative of whatever that is squared here? Then yes. Then if that's correct, then this whole thing fully satisfies that formula of hyperbolic tan inverse. Then we just make a conclusion now that, okay, the answer for this is just 1 over a, our a being 2. So it's guys gonna be 1 over 2 multiplied by the hyperbolic tan inverse of what? Of f of x. Our f of x being what? Being ln of x, and then over a, our a being 2. And then plus c. Ta-da! You have your answer. So easy like that. Easy, easy, easy like that. Makes sense, right? So yeah, that's just it. That's just it. So if you have crammed the formulas, then it becomes easy and exciting. Is it exciting, or we're just doing it for passing? But it looks exciting, isn't it? It looks like it's exciting if you are chopping it, but hey, if it's chopping you, obvious, yeah, we have to agree that maths is only exciting if you're getting it correct, but if it's chopping you, then you're just doing it because of it's part of your modules. But it's easy. With me, I believe you are seeing light nyana now, or you can see light for real, not just nyana. Anyway, let's continue. So now we've got the integral of x squared divided by what? divided by the square root of x to the power 6 minus 1. So we need to first rewrite this question in a nice way just to see that does it fit on any of the formulas that we know before we make a conclusion, because otherwise if it doesn't fit, then it has to be done through the general log rule or general power rule. Makes sense, right? So yeah, let's first rewrite it in a nice way. So that's the first step first. So first step first, we rewrite it in a nice way. So we're gonna leave that x squared untouched. We're not gonna touch it. So this square root of, so x to the power 6, we're gonna write it in an f of x to the power squared, to the power 2ish. So that means this is going to be x to the power 3 squared minus 1 squared dx. 1 squared is the same as 1, guys. I hope you're not having a problem with that 1 being squared like this. Yeah. So in the denominator, whenever we have the square root of f of x squared minus 1 squared, then this tells us that we're dealing with what? With that one of hyperbolic cos inverse, hyperbolic cos inverse. So we now know that, okay, this could fit maybe in that one of hyperbolic cos inverse. But before we conclude, we need to also make sure that on the numerator, we have the derivative of whatever that is squared here. So when we check x cubed, the derivative of x cubed is supposed to be 3x squared. And this one will only have x squared. So that means it's partially the derivative of this. So we need to complete this thing to be fully the derivative of x cubed. So we are going to put the 3 there. So when you put 3, so since you have now put 3, you need to cancel it out. Otherwise, that means you would have changed the equation that you were given, and it's not allowed. You cannot afford to do that. It's also very, very expensive to do that, So please don't do expensive things if you don't afford it. So yeah, 3 and 3, they cancel out, and then but then we're not gonna cancel them out. We're gonna make use of this one being fully the derivative of this, so that we can just then conclude that the thing that was differentiated for us to get this fraction was what? Was the hyperbolic cos inverse of f of x over a. Okay, so that means here our answer for this question is just gonna be, remember, whatever that's outside the integral goes with us to the answer. So that 1 over 3, we'll take it with us to the answer, and then we'll make a conclusion that that one is hyperbolic cos inverse. Hyperbolic cos inverse of what? Of x cubed. Just x cubed, then plus c. So it's x cubed over 1 basically. So the 1, we don't have to necessarily write it unless if you just like it that way. So yeah, it's just x cubed. So ta-da, that's your answer. Easy, right? Very easy. Very, very easy. Okay. Ooh. Okay, now we've got this question. Guys, remember, you are pausing the video, you try it on your own, and then later you check, okay, how did this guy do it? And then yeah, we should have gotten the same answer if you didn't make mistakes. So yeah, let's do this question. So now we've got the integral of square root of we've got the integral of 5 divided by x square root of 9 minus 16x squared dx. So the first thing first is to rewrite this question in a nice way. The nice way is having a squared, also f of x squared, so that we can see that does it satisfy one of the formulas that we have there. So now the first thing first is to rewrite it in a nice way. So I'm gonna take the 5 out, of course, because it's causing some disturbance here. I don't want to be disturbed when I'm solving here. So I have my x here, and then I have my square root of, so I'm gonna change the 9 to 3 squared. I hope no one is facing problems with 9 being 3 squared. And then now I also change 16x squared to be the same as 4x to the power of 2. and then I shouldn't leave out my dx, and then I have my 1 there on my numerator. So what did I do? I took the 5 outside the integral. Here it is now outside the integral. The x is still there, the square root is still there. So now okay, I can see that this format is going to be when I check on my formulas, is going to be that one of hyperbolic what? So I've got my a squared minus that is going to be my hyperbolic sec, right? It's going to be my hyperbolic sec. But before I conclude that, I must first make sure that here on my what? Here on my here where there is x, I have the same thing as whatever that is squared there. That's what the formula of hyperbolic sec inverse says. Also, on the numerator here, I must make sure that the numerator is the derivative of whatever that is here. Makes sense, right? So now I check. Okay. When I differentiate 4x, what do I get? I get a 4, right? So I must make sure that on the numerator, I have a 4. So I have a 4 there on my numerator. Also, here, I must make sure I have a what? A 4. So, okay. Technically, or what? Normally, I was supposed to make sure that I cancel out whatever that I have written if they were not there, you know. But now, I've written 4, again I've written 4, and I can see that this 4 and 4, they can just cancel out, and then I just go back to how the question was given, you know. But then, now that they are like this, sitting nicely like this, I don't have to worry about them because they take care of each other. They cancel out each other. And also, at the same time, they allow me to use one of the formulas that I have there. So if this is the derivative of whatever that is squared, and also this is the same as whatever that is here, then I can safely say the thing that was differentiated for me to get this quotient was what? Was inverse hyperbolic sec. So inverse hyperbolic says that I must have negative 1 over a. So of course I should also take whatever that's outside the integral to go with me to the answer. So I'm going to say negative 5 over a. So my a is 3. So basically this 5 is the one coming there. I'm just saying negative 1 over a. So my a is 3. So since this 1 is going to be multiplied by that 5 that comes with me from the outside of the integral, then let me just write 5. Makes sense, right? And then also I say hyperbolic sec inverse of what? Of f of x. F of x is what? Is just 4x over 3. And then plus c. Ta-da! You have your answer. So that's just it. That's just it. You don't have to worry about anything. So that's it. I hope you got it. It was an easy one. Really, it was an easy one. Even me, I managed to get it. Imagine. So I always get easy things, guys. So I always get easy things. So if I got if I get this question, it means that yeah, indeed it's easy. Okay, we've got this question as well. So before we conclude that it's any of the inverse things there, we have to first rewrite it first in a nice way whereby we can tell that this is f of x, this is f prime of x. So let's see. Let's go. So now we are going to say our this is going to be our integral. Okay, let's take the 4 out already. It's causing some disturbance already, and I don't want to be disturbed when I'm solving here. So I took the 4 out, and then I leave the x here, and then I have my square root of what? Of 1 squared plus what? Plus 9x squared. So 9x squared is the same as 3x to the power of 2 dx, you know. So what's happening here? Remember, so when I check this, I'm remembering that, okay, all right, this one can fit in that one of what? Of hyperbolic cosec inverse, you know. But then, before I make any conclusion ever, I must first make sure that whatever that is squared here should be the same here. So if it's 3x here, I'm expecting 3x here before I make any conclusion. Also, the numerator should be the derivative of whatever that is squared here. So that means if I have 3x here, I'm expecting to see 3 here because 3 is the derivative of 3x. So now I cook them because I'm allowed to cook numbers. So I manipulate, I write a 3 here and then another 3 here. Makes sense, right? So now that I have written 3 and 3, technically just like the previous question that we just did, I was supposed to write something here that cancel out this 3, write something again that cancel out this 3, but already for this question, this 3 and this 3, they cancel out, so I don't have to worry about canceling them or writing something that cancels them. So also I'm not gonna cancel them because it's gonna take me back to what the question was initially, and I don't want it to be like that for it to be answered. So I'm going to make use of 3 being the derivative of 3x and 3x being the same as this one, and this format being that one of hyperbolic cosec inverse. And then I make a conclusion now that this thing is the same as negative 1 over a. So my a is 1. So it's going to be negative 1 over a is more like negative 1 over 1 hyperbolic cosec inverse of what? Of f of x over a. So f of x is 3x, so it's 3x over what? Over 1. So it's just gonna be 3x and then plus c. Of course, whatever that's outside the integral should always go with me to the answer. So this 1 over 1 is going to be just that 4. You understand? So that 4, I'm taking it with me to the answer, and then tada, I have my answer. Make sense? It should. It's supposed to. So yeah, that's just it. Stay tuned. Let's see what we can do to this other question. I hope you're also doing some damages to this question, because if you don't, that means the damage is being done to you. It's being done to you, because there is no way damage has to be done at the end of the day. So it's either you're doing damage to the question or the question is doing some damage to you. So yeah, make sure the damage is not being done to you. Understand? So that's what I'm trying to say. So now we've got another guy here. This guy is the integral of 2x divided by 4 minus x to the power of 4 dx. So what are we doing here? We're integrating, but before we integrate, since we know that already that we are dealing with inverse hyperbolic function, you need to first rewrite this question in a nice way. So in a nice way whereby, so this nice way, it's you rewriting this question in the format of a squared f of x squared, so that you can see what is f of x and what is your a, and also what is your f prime of x before you make any conclusions. So that's what I'm going to do as well. So I'm going to say this is the integral of what? I'm going to leave that 2x untouched. So you 2x, I'm leaving you the way you are. And then you 4, I'm changing you. I've got a problem with you being like that. So I'm going to change you and become something else. And then minus as well as x to the power 4. I have a problem with x being to the power of 4. I don't want it to be like that. I'm going to change you and you look like a stylist nyana. So okay, anyway, let's continue. So I've got my x squared here. So x squared to the power of 2 dx. You understand? So what happened here? X squared to the power of 2 is the same as x to the power 4. 4 is the same as 2 to the power 2. So this format, at least it allows me to relate to what this looks like in the form of with regards to the formulas that we have of hyperbolic inverse hyperbolic functions, you know. So I go and check in my formulas or in my mind there, because I might have crammed this by the time I'm doing this question. So I check there in my brain, I find that, oh man, you look like that one of which one? Of hyperbolic what? This one looks like this one of hyperbolic tan inverse, because I've got my a squared minus f of x squared. So now that means I can just conclude now and say that, okay, I'm dealing with hyperbolic tan inverse. But before I fully conclude, I must make sure that on the numerator I have the derivative of whatever that is squared here. So I check, what is it that is squared? Is it x squared? So I found that, yeah, indeed it is x squared. So say I check, okay, when I differentiate x squared, what is it that I get? I get 2x. So I check, is the numerator the derivative of whatever that is squared here? Yes. And then this format, that means it is that one of hyperbolic tan inverse. Now I can then conclude and just write my answer now and say my answer to this integral question is just 1 over a. My a is what? Is 2 multiplied by hyperbolic tan inverse of what? Of f of x. Our f of x is just x squared over 2. Then plus c. Ta-da! You have your answer. So easy like that. Easy like that. Makes sense, right? It should. What do you want it to do? You want it to not make sense, you'll get destroyed. So you have to, it has to make sense at the end of the day. It must, it should, yeah? It must, even if it's not, it must at the end of the day. What are you gonna do if it's not making sense? You can't do anything. So anyway, let's quickly continue and solve this other one. So now we've got integral of e to the power x divided by the square root of e to the power 2x plus 1 multiplied by dx. So what's the first thing first? We know that we're dealing with inverses here in this video. So the first thing that we are supposed to do is to check, is to first rewrite this question in that format of being what? A squared f of x squared, and then so that we can see what's our f prime of x, blah blah blah. So before we make any conclusion, we rewrite it first in a nice way. So you're going to rewrite this question in a nice way. You do this and then you put a square root there. So this is going to be square root of what? When I write the square root, what's wrong with you? So you're going to write the square root and then you rewrite this in the form of f of what squared. So this is going to be e to the power x squared plus 1 squared. And then on the numerator, I'm not going to do any harm to e to the power x. I'm just going to leave it like that, dx, and then just like that. So now you analyze it, you check, okay, the format of having our denominator being square root of something like what squared plus a squared, which one is it? And then you find that, oh, that one is just that one of sine inverse. Okay, but before you make any conclusion, you must first make sure that on your numerator you have the derivative of whatever that is squared here. You understand? So when you check e to the power x, is it the derivative of e to the power x? Yes. Then now you're allowed to make conclusions now and say, okay, that means I'm dealing with a hyperbolic sine inverse of what? Of just e to the power of x. Cos of e to the power x divided by a is just e to the power x. So then plus c. Ta-da! You have your answer there correctly. So that's just it. Make sense? Yeah. I hope it does. Okay, now we've got another question here. We've got this question being the integral of 1 divided by the square root of 1 minus a to the power of 2x. So, okay, this one, it's tricky. It's tricky because of when we check here. Oh, all right, remember, we must always follow the steps for us to not get chopped. So now it's me, I'm an expert in this thing. So already I can tell what is what before. Like, it's more like I jump. I don't know. You see, when you are in my level now, it's more like you see these things in the spiritual realm, you know. I'm kidding, let's go with the procedure so that you can see that the procedure always works. So the first thing whenever you're dealing with these things is to make sure that you rewrite it in a nice way first. So what I'm gonna do here is this. So I'm gonna rewrite it in a nice way. The nice way is having a squared f of x squared so that you can see what is what. So I'm gonna have my 1 there on my numerator, and then I have my square root of what? Square root of 1 squared minus what? E to the power of x squared. And then I have my dx. So okay, when I check this guy here, I can see that maybe this thing was okay. I can see that okay, it looks like that one of hyperbolic sec inverse. However, I'm not happy with the fact that on the numerator is not the derivative of whatever that is squared here, but there is no other way that I can deal with this thing, or I don't know any other method that can enable me to integrate it then if this one is failing to be the derivative of whatever that is squared here. Because 1 is not the derivative of e to the power x. And for us to make a conclusion that, okay, this one is supposed to be e to the power, is supposed to be a hyperbolic sec. Also, that one of hyperbolic sec inverse, we are supposed to have what in hyperbolic sec inverse? We are supposed to have the same thing as whatever that is squared here. So here we're supposed to have e to the power x and e to the power x here. So so this one I'm already like telling you that this one is going to be hyperbolic sec inverse. So what happened here? So the thing that happened here is that okay, this question got destroyed, or it got simplified. The answer got simplified because of when we differentiate e to the power x, what do we get? We get e to the power x. So here we had e to the power of x. We had e to the power of x like this. And remember, here as well, we're supposed to have what? E to the power x, e to the power of x, I mean. So e to the power of x and e to the power of x, they got cancelled out before we were given this question, you understand? Hence now our question is given in this format, hence this question is given in this format now of having only 1. It's because of e to the power of x and e to the power of x, they were cancelled, or they cancelled out, you understand? But then let me also convince you in this way. Let's just make use of u substitution. So here for this question, just for the sake of convincing you that this thing is really sec inverse, we're gonna make use of u substitution. So we're gonna let our u to be equivalent to e to the power of x. And then when we differentiate this, so that means du is going to be equals to or du dx is going to be equivalent to e to the power of x. Therefore our dx here, if we were to make dx according to the formula, dx was going to be equivalent to du over e to the power of x. And we know that u is equivalent to e to the power x. That means where there is e to the power of x, I'm going to write what? U. So this is the same as what? As du over u. Hope that makes sense. So now I'm going to rewrite this question in the form of u so that y'all can get convinced of what is happening. So now this is what I'm gonna do. So I'm gonna write, so dx is equivalent to what? Du over u. So that means where there is dx, I can leave out this one. Where there is dx, I'm gonna write du over u. You understand? Du over u. And then inside I also have a square root here. I have square root of what? Square root of 1 squared minus u squared, just like this, because e to the power of x is equivalent to u. So where there is e to the power of x, I substitute u. Where there is dx, I substitute du over u. So I have my du over u here. So now let's take this u now, because these things are multiplying each other. Let's take this u and put it here. You understand? So let me take that u and put it there. So du, I take the u now, I put it here now. So now look at this format. Whenever we've got the same thing, whenever we have the same thing as the thing that is squared there, and also when our numerator allows to be the derivative of whatever that is squared there, then we can make a conclusion that whatever thing that we're dealing with there, it's hyperbolic sec inverse, you know. So that means here, look at it. When we differentiate u with respect to u, we're going to get a 1. Also, this u is the same as the u there. And this format allows us to conclude that we're dealing with hyperbolic sec inverse. So that means here we're just going to conclude and say our answer to this question is negative, because it's negative because of the formula says negative 1 over a. So our thing is going to be negative 1 over 1, negative 1 over 1, hyperbolic sec inverse of what? Of f of x. F of x for this case, it's a u. So it's just going to be u, then plus c. But then we're not dealing with u in our question. We're dealing with e to the power of x. So hence, yeah, we're going to further this question and conclude that this is the same as hyperbolic sec inverse of what? Of e to the power of x plus c. Then, ta-da! You have your answer. So hence I was saying initially here, I could tell that, okay, since the derivative of e to the power x is e to the power x, and here we always have e to the power x, so there is no way that this thing was gonna be something else instead of being sec inverse. So hence I had to also convince you in a nice way of using u substitution to show you that indeed this thing becomes hyperbolic sec inverse of e to the power of x. So there was no error in that question. So yeah, it was a nice one, right? A nice one. I love that one. It was very nice. A little bit tricky, but nah, not to us, right? Not to us. I be with you. All right. So here now we have the integral of 1 divided by the square root of 16x squared minus 25 dx. So we're supposed to integrate as well, but now that we know that we're integrating inverses, what I was supposed to do, we're supposed to make sure that we first rewrite this thing in a nice way so that we can see what's our f of x, what's our a, and then conclude that it is one of the inverses. So yeah, so let's first rewrite this question in a nice way. So what we're gonna do now is just to rewrite this question in a nice way. So we're gonna leave out that 1 the way it is before we do any damage to it. So let's leave out the 1 alone, and then we have our square root of what? We have our square root of what? We have our square root of 4x to the power of 2. 4x to the power of 2 minus 5 squared dx, like this. So already we can see that, okay, this format of having a square root in the denominator and what squared minus a squared is the format of what? Of hyperbolic cos inverse, right? Hyperbolic cos inverse. But before we make any conclusion, we should make sure that on our numerator we have the derivative of whatever thing that is squared there. So when we check, the derivative of 4x is supposed to be 4, and there we have 1. So meaning that we need to manipulate this or cook it. So let's cook that one. So when we cook 1 here, we are going to put just 4. So we're going to put 4. When we put 4, it means now we changed our question. So we don't want to change the question, guys. We want to solve the things that we're given. So we're going to multiply by 1 over 4. So that the 4 and 4 cancel out, and then it goes back to the 1 that we were given. But then we're not going to cancel out as well. We're going to make use of 4 because it satisfies one of the formulas that we have there. It satisfies the formula it satisfies that formula of what? Of hyperbolic cos inverse of something. So since now 4 is the derivative of 4x, then we can now make a conclusion that, okay, the thing that we are dealing with is hyperbolic cos inverse. So whatever that's outside the integral is going to go with me to the answer. So I'm going to have 1 over 4 multiplied by what? Hyperbolic cos inverse of what? Of f of x. So my f of x being 4x and my a being 5 plus c. Ta-da! You have your answer. So that's just it for that question. There wasn't much to be done there. Yeah, this is it. I hope you got it as well. It was really an easy one. It was an easy one. Okay, now we have the following questions. We have the following question. Integrate e to the power negative x divided by 4 minus e to the power of negative 2x dx. So what are we dealing with? Before we make conclusion, we need to first make sure we write it in a nice way, having a squared f of x squared, so that we can see that we have f prime of x or what. Yeah. So before we make any conclusion, we go here, we rewrite it in a nice way. So I'm going to rewrite this e to the power negative x divided by 4. I'm going to change it to 2 squared minus, and then this one I change it to e to the power of negative x to the power of 2. And then I write my dx here. So now I go check in my formulas. I see that, okay, there is a possibility that this could be one of the inverses, because I have a squared minus f of x squared, and then that format of a squared minus f of x squared is that one of hyperbolic tan inverse, you know. So before I make that conclusion, of course, I must make sure that on the numerator I have the derivative of whatever that is squared, yes, because this is our f of x and that's supposed to be our f prime of x. So when we check here, this one of e to the power negative x, when we differentiate it, we are supposed to get negative e to the power of negative x, you know. So when we check the numerator, we don't have that negative that we are talking about. So we need to put that negative sign. So when you put the negative sign, you should again cancel it out by multiplying by another negative outside the integral, you know, so that you don't change the question that you were given. Okay, so now that your numerator is fully the derivative of whatever that is squared there, and you've got this format that you already said that this format is going to be what? Hyperbolic tan inverse. So now you can then make a conclusion that whatever that you are dealing with is just hyperbolic tan inverse. So you're gonna take whatever that's outside the integral with you to the answer, so that negative will go with you, and then this one is going to be tan inverse, of course. So tan inverse is 1 over a, so it's going to be 1 over 2, because our a is 2 here, and then multiplied by the hyperbolic tan inverse of what? Of f of x. So f of x is the thing that is squared there, so it's e to the power negative x all over 2 plus c. Ta-da! You have your answer. So that's how we're supposed to get the answer for that question. So I hope you also reached to the same answer. I hope you did. I hope you did. I hope you did. Oh, I hope so. All right. Now we've got this following question. So what are we supposed to do to this question? We're supposed to make sure that we integrate it. But before we do that, before we integrate or do any damage to this question, we need to rewrite it in a nice way first. All right, so let's then rewrite this question. A nice way is us having a squared f of x squared. So let's rewrite it in a nice way first. So you write this question in a nice way. You do this. You then say, okay, I have my 2x, yeah, multiplied by the square root of what? Square root of what? Square root of what? So I've got my 1 squared there minus so 9 is what? Is the same as 3x squared, right? And then here I've got my dx there. I've got my dx there. So on my numerator, I have my 1. So what damage have I done to the equation? I only changed 9x squared to 3x squared. And then 2x, I didn't do any damage to it. I kept it the way it was. So now we go to analyzation of the equation. So, okay. In questions whereby we have this format of having something here multiplied by the square root of a squared minus f of x squared. So this is our f of x, 3x, by the way. So this format of having something like this is that one of hyperbolic sec. Is the one of hyperbolic sec. So I know that I'm dealing with hyperbolic sec in this question. So what am I supposed to do? I'm supposed to make sure that here I have the same thing as whatever that is here, you know. So if this is 3x, then I must make sure that here I have 3x as well. So 2 here is on my way here of making it a success. So I must get rid of these 2, you know. I must get rid of these 2, but without changing the equation. So this 2, it's gonna be easy for me to get rid of it. I'm gonna take it out to outside the integral, you know. So what I'm gonna do here, I'm gonna get rid of these 2. So I'm gonna leave this x here, and then 1 over 2. So that 2 that was here, now it's out of them. It's out of my way now. I got rid of it. It's outside the integral. Now the only thing that I'm left with is just to make sure that here I have 3x, because the f of x is supposed to be f of x as well as here. So if this is our f of x, we are supposed to also have f of x according to the equations, the formulas that we are dealing with. So 3x is, it's supposed to be 3x as well. So here I'm supposed to write another 3. Okay. Before that, before I do anything to this 3, I must also again make sure that on my numerator, I have the derivative of whatever that is squared here, which is my f of x. So when I check, the derivative of 3x, it's supposed to be 3, but I have a 1 there. So I need to manipulate that 3 by just cancelling out that 1 and write the 3. So technically, I was supposed to write something outside the integral that will enable me to cancel out the 3. And also again, write something else that will enable me to cancel the 3. So for this question, fortunately enough, the 3 and the 3 that I wrote already, they cancel themselves out. So I don't have to worry about them, you know. But then I'm not gonna cancel them out, of course, because I'm gonna go back to how the question was, and I don't wanna go back. I wanna answer this question. So if I have 3 as the derivative of whatever that's squared here, and 3x is the same as 3x, so then I can make a conclusion that this format that I'm dealing with is that one of hyperbolic sec inverse, you know. So now I then conclude that this is going to be negative 1 over a. So this is negative 1 over a, our a being 1, so it's going to be negative 1 over 1 multiplied by the hyperbolic sec inverse of what? Of f of x being our 3x over 1, then plus c. So of course I shouldn't forget to take whatever that's outside the integral, with me to the answer. So meaning that what this 1 over 1 is, I'm just going to replace it by 1 over 2. So here I'm just going to replace it by 1 over 2. Then tada, I have my answer. So that's just it. So for that question, I hope you also got the same thing. That was it for that question. And then now we proceed. We reach here. Okay. So on this question, we have what? We've got the integral. Remember, guys, you are pausing these videos before so that you all attempt them on your own before you check how I have done them, right? So now we've got this question now, integral of 1 divided by x ln of x to square root of 2 minus ln of x squared, then dx, of course. So remember, since we're dealing with inverses, we need to first rewrite it in a nice way or in the format of inverses so that we can tell which inverse are we dealing with here. So to do that, okay, I can see that this one is squared. So I can take x upward again. Remember, there is 1 here. It is 1. So if I take this 1, I lift it up. It's going to lift this 1 again as well. You know, it lifts this 1. So this question will end up looking like this. It will end up looking like 1 over x. You see that x, it lifted that 1 that was there. So that's the damage I did to this question so far. Let's check what other damages I can do to this question. It seems like I'm on a mission here. I'm doing some damages to this question. So now let's rewrite this 2 also in the form of a squared. So it's the same as square root of 2 squared, right? Minus, we write ln of that squared in the form of what squared as well. So this is going to be this squared, and then I write my dx. So okay, this is the damage I did so far to this question. Look at it. So I have what? I have okay, I took x up because I saw that, okay, this must be my f of x, because I know that always whatever that is here squared is my f of x. So I saw that, okay, that's going to be ln of x, and the derivative of ln of x is what? Is 1 over x. So hence I took this x up. So I took the x up, and then it became like this. And then on my side here, I know that whatever that is squared should be the same as with the thing that I have here. And then now now that things are like this, I have something which is the same as whatever that is squared there. Now I can go to my formulas now, and I go check that this denominator that is like this, does it fit to be any of the inverses? I go check. If I have a squared minus this, of course, this fits to be that one of hyperbolic sec inverse. Okay, so now that I'm aware that, okay, I might be dealing with a hyperbolic sec inverse, so before I fully conclude that it's gonna be the hyperbolic sec inverse, I must make sure that whatever that's on my numerator has to be the derivative of whatever that is squared here. You understand? Because whatever that's squared here, we treat it as our f of x. So when I differentiate ln of x, what do I get? I get 1 over x, which is already what I have there on my what? On my numerator. You understand? So I then come to my answer now. I then go to my answer. I conclude that, okay, the answer for this question is just going to be negative 1 over what? 1 over a. My a is what? It's square root of 2. So negative 1 over square root of 2 multiplied by hyperbolic sec inverse of what? Hyperbolic sec inverse of what? Of f of x. So my f of x is what? It's ln of x divided by what? Divided by square root of 2, and then plus c. Then tada, you have your answer there. Of course, one of you would like to write 1 over root 2 as root 2 over 2 is the same thing, and then if you want to change this as well, it's going to be root 2 over 2. So either you work with 1 over root 2 or root 2 over 2. Both are the same. They're equivalent to each other. 1 over root 2 and root 2 over 2, they are equivalent to each other. They are the same. So yeah, I prefer 1 over root 2. I work better with 1 over root 2. Makes sense? Okay, yeah, you should have gotten to that answer as well. So let's check another question here. We have this question. Okay, here we have this question now. We've got integral of we've got integral of 1 divided by 2x square root of 1 minus 9x squared dx. So what are we trying to do here? We're trying to integrate. So I already solved these questions. All right, I think this question is repeating, guys. I already solved this question of 1 over this. I already solved it. So So please let's not do it. I already solved it. Here it is. Here it is, guys. I already solved it. So don't worry about it. I just repeated it. So solved. Already solved. Already solved. All right, already solved. So tada, you already solved this one. Let's quickly check other ones that we haven't solved then, because we can't be repeating the same question. Of course you can repeat it. What if it chops you and we already did it, but it can chop you? So please give it a try and see if you can chop this question. Give it a try, pause the video, give it a try. Let's see if you're gonna get it, because the chances are you might get chopped, you know, and be surprised that but I already did this question. What's happening now? Will I survive this maths? So yeah, try yourself, Dre. Challenge your brain. Okay, we've got another question here. Okay, we know that we're dealing with inverses, right? What's the first step that we do? We check. We check by first rewriting it in that format of having a squared, f of x squared, and then we see that, okay, does it fit to be one of the inverses? Okay, so here that's the first thing that we're gonna do. If it fails, then we know what to do. We don't stop. There is nothing that we cannot solve, right? Unless if we, I don't know, let's not put unless, we solve everything. Okay, so this one we're gonna put, so this is how you should think every time, as well as in the test. It will enable you to get a correct answer. Sometimes when you are now too confident, you'll see that sometimes you don't have to really write it in a nice way. When you are too good now, when you're maybe in my level, then yeah, of course you can just write the answer. I'm just doing this, I'm just prolonging them because of, you must understand them, you know. If I were to write this one, I would just write the answer at the same time. I can see what is happening. Like, I don't have to check which rule to use. I know which rule to use same time. It's more like I can see these things in the spiritual realm. God just put them in my brain. Say, son, that's the answer is just 2x plus 1 there. You see, if it's 2x plus 1, of course. Anyway, let's continue. So to rewrite 25x squared in that format, it's going to be 5x squared plus, and then 36 is the same as 6 squared dx. Okay, now we check. Now before we make any conclusion, we check, because the most important thing is to check. So we check, okay, this format of having square root of something squared plus a squared could be that one of what, hyperbolic sine inverse. Could be, you know. So we are not sure right now, we are still checking. So we check, okay, the chances are I might be dealing with our hyperbolic sine inverse. So I go to my numerator now. I check, you numerator, can you be the derivative of whatever thing that is squared there? I check, okay, the derivative of 5x, how much is it supposed to be? It's supposed to be just 5. But now I have a problem that I have x, you know. So since I have x and I know that when I differentiate 5x, I only get 5. That means it tells me that no, we are not dealing with inverse hyperbolic sine here. It's something else. It's something else, you know. So immediately when we're dealing with something else, you should know that now we need to then try to find out, can we make one f of x and the other one f prime of x? What is the goal here? If we try to make one f of x and the other one f prime of x, the goal is to make use of general power rule or general log rule. So we check. Okay, so I'm gonna erase this, guys. So this one is not gonna work because of what I already told you. You understand? So this is how you'll be thinking as well in the test. Sometimes you don't really have to do it on paper. You must do it in your brain if you are now good. So let's erase this. So it didn't work that way. You understand? So now we check. If we let the numerator to be f of x, can this be the derivative of x? No, because we know that the derivative of x is 1, right? Okay, how about we just take whatever that's inside the square root to be the derivative of to be f of x. So if we let 25x squared plus 36 to be f of x, can x be the derivative of this? Yes, but so far partially it is the derivative of this, so it's missing a coefficient there. So we need to correct that coefficient by cooking. So let's also first rewrite this firstly in a nice way, because already we can see that we've got a potential of using general power rule. So before we conclude our general power rule, we have to make use of rewriting this question in a nice way, so that we can really be convinced that okay, yeah, indeed, yeah, we are using general power rule. So first thing first, we rewrite this question nicely. So I'm gonna put my x here before I do any damage to it. So let's do damage to the 25. What there? So 25 x squared plus 36. I'm gonna do this to it, and then I'm gonna take it up. So what I'm doing here, I'm taking this square root up, so meaning that it's gonna, I'm taking the square root up and then also rewrite in the exponential form. So it's gonna be negative 1 over 2 dx. So that's the damage I did. I took the square root up and it changed the sign of its exponent. So that's it. So now I know that I'm supposed to use general power rule because of my n here is not equivalent to -1, and I've rewritten this thing in the product form. So if it's not equivalent to -1 and it's in the product form, then I must use a general power rule. So if this is my f of x, this is supposed to be f prime of x before I make use of my general power rule. So I know that when I differentiate 25x squared, I get what? I get 25 times 2. How much is it? It's 50, right? So 25 times 2, 25 times 2, it's a 50, 5 naught. So here I'm supposed to have 5 naught. 5 naught, 50. 50x for this thing to be fully the derivative of what I have there inside the bracket. So another thing, because of this 50, I didn't have it in the question. It means that now that is there, I've changed the question. So I don't want to change the question, guys. It's not allowed. It's also very expensive. You cannot afford to do it. You understand? You cannot afford to do it. Please trust me. So you need to cancel out this 50 by writing another 1 over 50 outside the integral, so that 50 and 50 they cancel out. But then you don't cancel them out, of course, because you don't want to go back to how the question was. You are trying to answer this question. So now that you have the derivative of whatever that is inside the brackets here, then you can just make use of general power rule. General power rule states that if you have f of x and this is f prime of x and the n here is not equivalent to -1, then you can just say your answer to this integral that you're dealing with is just this f of x together with its n. Then you just you add +1 to the n and then divide by n plus 1, of course, and then you say plus c. And then you shouldn't also forget to take whatever that's outside the integral with you to the answer. You understand? You shouldn't forget to take this with you to the answer. So that 1 over 50 will go with you to the answer. So we're gonna have 1 over 50 multiplied by so now we apply our general power rule. So general power rule there is just gonna be 25 x squared plus 36. 25 x squared plus 36 to the power -half plus 1 is going to be +half, and then you divide by that +half, then you say plus c, and then 50 multiplied by half is just gonna be 25. So at the end of the day, you're gonna have square root of what? Of 25 x squared plus 36, all divided by just 25 plus c as your answer. Then tada, you have your answer. So I hope you reached to the same answer as well. It was an easy one. So let's stay tuned. Let's quickly do the following ones. Okay, here it is. So now we've got what is this? We've got the integral of x plus 1 all divided by the square root of x squared plus 9 dx. So what are we doing here? We are integrating. So before we integrate, I just want to remind you that this is one of the questions whereby we must make separations of the terms in the numerator so that each and every term in the numerator have its own denominators that then we can be able to integrate. So that's what I'm going to do here. So I'm going to say the integral of x divided by the square root of x squared plus 9 x squared plus 9 dx plus the square root of what? Square root of what? Of 1 divided by x squared plus 9 dx. Okay, so I'm supposed to integrate the two, guys. Okay, so let's start with this one on my left. So on this question, since we know that we're dealing with inverses, of course the first thing that we need to do is to check that can what? We need to rewrite it in a nice way first. So if we were to rewrite this in a nice way, this was going to be x squared plus 3 squared. The same applies to this, yeah, it applies to this. So this is just gonna be x plus 3 squared. You understand? So now when we check this question, we can see that okay, this is inside the square root. Sorry, this left hand side, there is a square root there. There is a square root of x squared plus 3 squared. So I'm just sorry for that. I might be getting exhausted. Okay, yeah. Anyway, what I was saying that is that we need to first check that does it fit to be any of the inverses, and then when we check our denominator, okay, this denominator allows us to use hyperbolic sign inverse. However, we can't make a conclusion right now before we make sure that the numerator is the derivative of whatever that is squared here. You understand? So when we check x, the derivative of x is supposed to be 1, and already there on our numerator we have x. So that means this one, it fails to be one of the inverses. You understand? So that means we must try to make one f of x and the other one to see if the other one can be f prime of x, of course, and then so that we can end up using general power rule or general log rule. Okay, so how about this side? So on this side, when we check, so we're gonna check the inverses first. So when you check the inverses, x here, if it's our f of x, so that means on our numerator we should have the derivative of x. So when we differentiate x with respect to x, we get 1, right? And then what? Plus a squared here. Okay, so this one, when we check this format of having square root of x squared plus a squared, it fits to be that one of hyperbolic sign inverse, you know. So this one, that means what, it fits to be one of the inverses. Already we have the derivative of whatever that's squared there, so we don't have to worry about it. So now we can come back to this one. We'll say this one can't be one of the inverses, so we have to try to use general power rule. To use general power rule, one has to be f of x and the other one has to be f prime of x. So we check, if we let x to be f of x, can this be f prime of x? Definitely a no. So let's again also rewrite this nicely like this, like in that way of x squared plus 9 like this, so that it can be nice. Okay, how about we let x squared plus 9 to be our f of x? Can that one be f prime of x? Partially, yes, it can be, because of we know that when we differentiate x squared plus 9, we get 2x. So the only missing thing there is a coefficient of 2. So we need to correct that coefficient by multiplying by 1 over 2 outside and then put a 2 here. So another thing that we need to do is to rewrite this. Allow me to erase this and rewrite it in a nice way so that we are able to use general power rule nicely. So I'm going to take this square root up and then change the sign of that change the sign of the exponent. So I know that I have x here multiplied by square root of x squared plus 9 to the power negative half, like this. So what did I do? I took the square root up and then I rewrote it in exponential form. Of course, the sign of the exponent changed because of I took the square root up, so it became negative. So now the only thing that I need to make sure is that here I have the derivative of this. So the derivative of that is going to be 2x, but because of I didn't have this 2, I cancel out the 2 by writing out 1 over 2 outside the integral. So now I then just make use of general power rule because of my n is not equivalent to -1. If general power rule is chopping you, kindly go back to my videos. You will see the videos previously that I uploaded. I don't know activity what ban kwala. You will see that there is the activity for general power rule. So I think I wrote it as integration by substitution, I think. So yeah, you will see it like that. Okay, anyway, let's quickly continue. So here we're going to have okay, whatever that's outside the integral should always go with you to the answer. So it's going to be 1 over 2. We apply general power rule here. It's going to be x squared plus 9 plus okay, exponent there, we add 1 to that exponent. So a -1 over 2 plus 1 is going to be positive half divided by a 2. Divided by 1 over 2, I mean divided by 1 over 2, plus this side we already discussed it, that is going to be inverse hyperbolic sine. So this is going to be inverse hyperbolic sine of what? Of x over a, which is 3, and then plus c, and then of course here the 2 and 2 are going to chop each other. At the end of the day, we're gonna be left with square root of just x squared plus 9 plus a hyperbolic sine inverse of x over 3 plus c. Then tada, you have your answer. So that's just it for that question. I hope you got it as well. There was nothing tricky there. It's just maths. Makes sense, right? Okay, now we have this question here. So this question says that, okay, before we talk about it, let me just align it nicely, give it enough space. Okay, yeah, we have this question here that says that the integral of 3 divided by x plus 1 multiplied by the square root of 2x squared plus 4x plus 6 dx. So before we think of anything, we're already given the hint here. So the hint says that we should complete the square of the polynomial in the radical. So the radical is the square root. So this is the square root that we have here. So we need to complete the square. Okay, we're given a hint, so that means let's go with the hint. So let's complete the square. I don't need to explain much here because we're already given the hint. Otherwise, if we're not given the hint, we had to analyze it on our own, but they made our life easier for this case. We have an easier life for this. I don't know, 2 minutes, 3 minutes of solving this question. At least our life is easier because we are given the hint. Multiplied by, so they said inside the square root we must complete the square. So for you to be able to complete the square, you must make sure that the first term, or the term that is what squared, should be a perfect square. So this one is not a perfect square, because of 2 is not a perfect square. Perfect square numbers are what? Are 1, 4, 9, 16, blah 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 blah. You understand? So and so on and so on and so on. So we need to make sure that here we've got a perfect square. So to make sure that this one is a perfect square, we need to take out 2 as a common factor for this whole thing inside there, for the whole polynomial inside the square root. So we'll be left with x squared plus 2x plus a 3. And then okay, 2x squared, 4x, 6, okay, dx. And then the next step here is to make sure that I give 2 its square root and also this bracket its square root. So meaning that the following step here that I'm gonna do is to make sure that the 3 on top there, it's still there, and then the x plus 1, it's still here, but then 2 I gave it its own square root, and then also that other bracket I gave it its own square root. So it's going to be x squared plus 2x plus 3. Then I have my dx here. So here's the dx. So what's going to happen now, I'm only going to complete a square here inside this radical sign, because now I have a perfect square. I have 1x squared. So this is a perfect square. 1x squared is a perfect square. Perfect square, I mean. Okay. All right. So now for the following step, I'm going to take this 3 to go outside the integral. So I will end up having I think I'll take out 3, this 3 over root 2. 3 over root 2, I'll take both of them to go outside the integral there, because they are disturbing me. So I'll have 1 over, not 1, basically 3 over root 2 to go outside my integral, and then I'll be left with 1 there, and then my x plus 1, it's still here. And then now I try to complete the square. So to complete the square, the steps are very simple. You first square the first term. So you square the first term. So when we square the first term, it means that we put a radical sign where there is squared. I will be left with x to get the first term there. And then for you to get the term here, I'm gonna explain completing the square nicely in the following videos. There is an activity whereby we solve a lot of questions using completing the square. So for now, let's just summarize it. Let's not really entertain completing the square. If it's chopping you, please you'll check the videos that follows this one. There is an activity that involves completing the square. So yeah, for now I'm just gonna summarize it. So for you to get the term that comes here, you say middle term divided by 2 times the number that is here, or 2 times whatever that is here. So it's going to be plus 2x divided by 2 times x. So that's a 1. So we have a plus 1 here, and then you square. And then for you to get the term that is here, you say on your calculator, the number that is here squared. So it's going to be 1 squared. You say plus, and then you put any variable, like it's more like you're solving in your brain. So it's more like you're saying 1 squared plus x plus. So we're trying to solve here. So here, you equate it to what? You're trying to solve the number that is here, right? The number that is here. We're trying to solve for it. So it's more like you say, for you to find that number that is here, you say this number that is here squared. You say 1 squared plus whatever that is here, you represent it as x, like in your brain. I'm just showing you what is happening in my brain right now. So it's going to be plus x. So the thing that is here, you equate it to I mean, like whatever that you said here, you equate it to the number that you had initially there, which was 3. So that you can be able to solve for it. So here, this is going to be, our x here is going to be equivalent to 2, because it's going to be 3 minus 1. So that means here we have a plus 2. You understand how I solved for the constant there? So that's how I corrected the constant. Of course, when you expand this, you're going to get x squared plus 2x plus 1. So 1 plus 2, then it goes back to here. So meaning that we didn't change the question. We are still solving the same question. Okay. Now, our question is a lot better. Now we can say that, okay, this can fit to be one of the inverses. So, but before we make any conclusion, we need to first check if it fits to be any of the inverses, of course. So we check this format of having plus there. It's the one of cosec inverse. Okay. So okay, this can be cosec inverse because of whatever that is here is the same as whatever that is squared there. So we need to also again make sure that on the numerator we have the derivative of whatever that is squared here. You understand? So x plus 1, when we differentiate it with respect to x, we get 1, the one that we already have here. You understand? So meaning that this question is nice then. Okay, another thing, let's also rewrite this thing in the form of a squared. So let's write 2 in the form of a squared is the same as 2 square root of 2 squared, just like that. This is the same as 2 squared. I hope you don't have a problem with that. So now that I've already discussed with you that, okay, this one fully satisfies the formula of hyperbolic cosec inverse, then I can then make a conclusion. I take whatever that's outside the integral goes with me to the answer. So I'm going to have 3 over root 2 multiplied by negative 1 over a. So negative 1 over a. My a there, it's what? It's root 2. So negative 1 over root 2 multiplied by hyperbolic cosec inverse of what? Of my f of x is what? It's x plus 1 divided by root 2 and then plus c. Ta-da, you have your answer. And then of course root 2 and root 2 will multiply each other, and then you will end up having negative 3 over 2 here, just like that. And that thing there makes sense, and whatever that you have there. So that's what is going to happen. You'll have negative root 3 over 2 for the numbers that are multiplying each other here. So, and then that will be it for that question. Then you're done. So yeah, it was easy as well. Okay, let's look at this one. Okay. Okay, we've got another question here. So on this question, the hint as well, we're given the hint as well that we should complete the square. We should complete the square as well. So the hint says that we should complete the square as well for this question. So let's complete the square. It's a hint we are given. Hint, complete the square. You are given. Okay, so now what we're gonna do here is to say is to put the integral, and then you leave hyperbolic cos of x the way it was, and then you say divided by, you say divided by what? By what you get when you complete the square. So let's complete the square now. So okay, already this is a perfect square, so we're just gonna put the square root on it, and then we get the first term that we have here, that we should have there. So that's going to be hyperbolic sine of x. And then for you to get the next term here, you say the middle term divided by 2 times what you have here. So that's going to be 4 hyperbolic sine of x divided by 2. So this is going to be only plus 2. Because we're going to have hyperbolic sine, and hyperbolic sine will cancel out. 4 divided by 2 will be left with just 2. Then you square it, and then for you to get the number that is here, you say the term that is here squared. So that number that is there squared, you do it in your brain. I'm just writing it for you to have logic of what's happening in my brain. And then here you say you name this thing that is here as x. So here I'm gonna say plus x, and then you equate this thing to whatever that you had initially there, which was 2 for that case. So after that, you then solve for x so that you can get the number that is here. So you solve for this x. So this x is going to be equivalent to what? To -2, right? So this x is going to be equivalent to -2. Okay. Is going to be equivalent to -2. So I'm gonna write -2 here and then erase everything here. Of course, when you solve this, if you were to validate that you completed your square completely, you can just factorize this. So this is going to be hyperbolic sine of x squared plus 4 times hyperbolic sine of x plus 4 minus 2, then it goes to plus 2 there. So that means we're fully completed our square correctly. So now we need to, okay, let's just rewrite these two in the form of what? Of a squared. So this is going to be the same as square root of 2 squared. And then now we go check that does this formula fit to be any of the inverse formulas that we have. We check, okay, does it fit? We check, yes, it fits to be that one of what? Of hyperbolic chord, right? It fits to be that one of hyperbolic chord. Hyperbolic chord inverse. So this one is going to be hyperbolic chord inverse. So basically it could be done in two ways. One of you could say, I want to take negative as a common factor for the denominator, so that this one could be that one of hyperbolic tan inverse. So it's up to you. I'm gonna solve it maybe in two ways, just to flex. I don't know how I'm gonna flex them. Okay, now that we have identified that is going to be it could be that one of hyperbolic chord inverse, then we need to only just make sure before we conclude that on the numerator we have the derivative of whatever that is squared here. So when we differentiate whatever that is squared there, we get, so the derivative of hyperbolic sine inverse of x with respect to x is going to be the hyperbolic cos of x. So meaning that what I have on my numerator is the derivative of what is squared here. You understand? So meaning that now I can then just conclude that my answer to this question is negative, because we said it's going to be that one of chord inverse. So it's going to be negative 1 over a. So it's going to be negative 1 over root 2. So root 2 is our a, multiplied by chord inverse. Hyperbolic chord inverse of what? Of hyperbolic sine inverse of x plus 2. All of this divided by what? By a, which is root 2. And then plus c. Tada! You have your answer there. Just like that. So that's how we do it. That's how we basically do it. You understand, right? Yeah, you should. Alternatively, one of you could argue here and say, I want to take out negative as a common factor and force this one to be so from here. So this is an OR thing, okay? It's an OR thing that I'm doing. OR. So this is an OR thing. One of you could have taken the negative there as a common factor. So when you take the negative as a common factor in your numerator, you'll end up having negative what? Negative so we would have negative square root of 2 squared minus what? Minus hyperbolic sine inverse, hyperbolic sine of x plus 2 squared. And then you close the bracket, of course. You have your dx. You still have your hyperbolic cos of x here. Then dx. So what's happening here? And then after that, that person was going to take the negative outside the integral. So when you take the negative outside the integral, you're going to have that negative there. You remove the brackets. You understand? So now, when we analyze this format of having a squared minus f of x squared is that one of tan inverse. Is that one of what? Of tan inverse. So then that person will conclude and say the answer for this question is just negative 1 over a. So our a, it's root 2 hyperbolic tan inverse of what? Of my f of x being hyperbolic sine of x plus 2, and then all divided by what? All divided by square root of 2, and then plus c. Ta-da! You got the same answer. So both this answer and this answer are the correct answers for this question that we are dealing with here. So it's up to you which one you prefer the most. So that's just it. And then one of you again could have written 1 over root 2 as root 2 over 2. It is the same thing. I repeat, root 2 over 2 and 1 over root 2 are equivalent. So yeah, it's the same thing. Anyway, we're almost done with this video, so let's quickly check if we can do definite integrals. So let's quickly solve some of the definite integrals and then we'll be good to go. So just 6 of them and then we're done. So the first question under definite integrals is going to be evaluating the integral of 1 over 25 minus x squared dx, of course, upper limit being 4, the lower limit being 3. So we still, since we're dealing with inverses, we should still approach these questions in that way of having to rewrite it first and check if it fits to be one of the inverses. So yeah, that's what I'm gonna do first. First step is to rewrite this thing. So I have my 1 there on my numerator and I have my dx here. And then this 25, I'm going to change it to a squared. So it's going to be 5 squared minus this x squared is going to be in bracket x and then squared dx there. So I check on my formulas, do I have this thing of having a squared minus f of x squared? So I check and I find that one is that one of hyperbolic tan inverse. So I know that I'm dealing with hyperbolic tan inverse. So before I conclude, I also need to make sure that on my numerator I have the derivative of whatever thing that is squared here. So the derivative of x is 1, the one that we already have here. So that means here for this question we're just going to conclude that the answer for this integral is just 1 over a. Our a is 5, right? And then hyperbolic tan inverse of what? Of x over 5. And then we're not going to put plus c because we're dealing with the definite integral. So we're going to put the limits instead. So the upper limit on top and the lower limit below. And then from there, we then substitute our limits to find the answer for this definite integral. So this is going to be 1 over 5 hyperbolic tan inverse of what? Of 4 over 5 minus 1 over 5 hyperbolic tan inverse of what? Of 3 over 5. And then I'm gonna punch in my calculator right now. I'll let you know what I get. So for now, be patient with me as I punch this thing. So hype tan inverse is number 6, and then I put my 4 over 5 minus 1 over 5 hype 6, and then please don't forget how to punch inverse hyperbolic functions on your calculator. You have to make use of HYP, that is under x squared there when you check your calculator. So yeah, you have to make use of that one. You should be able to get something like 0, 0,0811. So that should be your answer that you must have gotten when you calculate there. So yeah, that's it for that question. I hope you got the same thing as well. It was an easy one. So let's quickly solve the following ones as well. So we have this one. We have this one, this question here as well. It says that the integral of 3, the definite integral of 3 divided by the square root of 9x squared minus 4 dx. So what are we doing? We also have our limits of 6 and 1. So we should integrate. So since we are dealing with inverses, we have to first rewrite it in that way of a squared f of x squared to see what's our f of x, what's our a, and then we make a conclusion after that, which we are dealing with this inverse. So now the first thing first is to be rewriting it in a nice way first. 6 1, and then I can leave okay, I can take out the 3 outside because I can see it's not gonna be of use if it's up there. So 6 1, so I'm gonna take the 3. So the 3 I took it out, so now I'm rewriting this question nicely. Is it gonna be, yeah, it's gonna be of use. I'm gonna take it back. I analyzed wrong. It's gonna be of use, guys. So I'm gonna rewrite 9x squared as in this format of 3x all to the power 2 minus 2 squared, and then dx. I'm gonna bring back my 3 there. 3 go back. So the 3 went back inside. I misanalyzed there. I rushed, so I thought it's not gonna be of use. Okay. Why is it of use? It's of use because of I can see that, okay, first thing first, the format of this one, whereby I have a square root of f of x squared minus a squared, is that one of hyperbolic cos, right? I'm dealing with a hyperbolic cos. So before I make a conclusion, of course, I must make sure that on the numerator, I have the derivative of whatever that I have here, which is squared. So 3x, when I differentiate it, I get a 3. The 3 that I already have, it was given to me in the answer. Then from here, I conclude that the thing that was differentiated here was hyperbolic cos inverse of what? Of f of x being 3x divided by 2. 2 as being our a there. So 2. And then I put my limits 6 and 1. And then I'm done there. I'm done. I'm not done, of course. I need to substitute the limits for me to get my answer for this definite integral. Then I'm going to say hyperbolic cos inverse of what? Of 3 multiplied by 6 divided by 2 minus the hyperbolic cos inverse of what? Of 3 multiplied by 1 divided by 2. And then I get the answer there. So the answer to this definitely is going to be what? So I'm punching now in the calculator. Be patient with me. So that's 5 cos is 5. 3 times 6 divided by 2 minus 5 cos it's 3 divided by 2. You should be able to get something like let's see if I didn't make a mistake. 3x over 2. Okay, 6 and 1 cos. Okay, I'm getting something like 1 comma 1,192 1 comma 192 1,92, so 1,9248. But before, let me also verify this answer by substituting everything on the calculator there. So just a second, I'm just substituting everything. I've got a doubt for this thing, this one a little bit, not much, of course, not much. So just a second, let's see how much I get here to see if I did a mistake or what. So the calculator is still loading. It's still loading. Yeah, I didn't do a mistake, so it's correct, guys. It's correct. You should have gotten the same thing provided that you didn't make a mistake. So that is the answer that one of you should have gotten. Yeah, this is the correct answer. 1,9248 is the correct answer. So now let's quickly check another one. We are almost done with this video so that we can get to another chapter. So now we've got our definite integral of x divided by what? by square root of x squared minus 15 dx, upper limit being 8 and the lower limit being 4. Already you can tell that this one cannot fit to be one of the inverses because of x. We cannot differentiate x. Remember, x here is going to be our f of x when we rewrite this thing nicely. So x cannot be the f of x because of when we differentiate x, we won't get x again. You understand? We're supposed to get one. So this tells us that we're supposed to use either general log rule or general power rule. So it's not going to be general log rule because of if we let our f of x here in our denominator, our x squared minus 15 to be our f of x on our denominator, then the n here it's negative, it's positive half. And for us to be able to use our general power rule, our n is supposed to be equals to 1 if it's in the denominator, if the f of x is in the denominator. So this tells us that we're using general power rule. So let's rewrite it in the format of general power rule. So this is gonna be 8, 4, and then I leave my x here. I leave my x here. I take the square root up. It's gonna be x squared minus 15 all to the power negative half, and then I put my dx there. So what do I have here? I have my f of x being x squared minus 15. So since f of x is my x squared minus 15, then I need to make sure that whatever that's outside there is fully the derivative of this, okay? So when I differentiate this with respect to x, I get what? I get 2x, but here I only have x, meaning that this is partially the derivative of this, so I need to complete it by putting a 2. But then I didn't have this 2 again, so I need to cancel it out by writing out another 1 over 2 outside the integral so that the 2 and 2 can cancel out. So if I have the f of x and the f prime of x, and f of x, and my n here is not equivalent to -1, then I must make use of general power rule to be able to integrate this. Of course, I must take whatever that's outside the integral with me to the answer. So this 1 over 2 that's outside the integral will go with me to the answer. And then I apply my general power rule. There is going to be ax squared minus 15 to the power negative half plus 1 is going to be positive half divided by half there. And then I put my limits 8 and 4. Of course, this one, the 2 and half will cancel out. Will end up only having square root of x squared minus 15 to the power, and then the limits being 8 and 4. Then I substitute my limits there for me to get the answer. It's going to be square root of what? Of 8 squared minus 15 minus square root. I substitute the lower limit now. This is going to be 4 squared minus 15. So let's see what we get with the calculator. If your brain is that good, you can also use your brain. My brain is not that good, so I'm gonna use the calculator because of the brain is not that good. So if you don't have a brain that is good like me, please make use of a calculator. So 4 squared minus 15 here, I'm getting something like exactly a 6. So this is 6 that I get. So you must have gotten a 6 as well for you to have gotten the correct answer. So that was it for that question. I hope you got it. Let's quickly see if we can solve the other questions. Then we'll be done with this video. Okay, we've got the integral of what? Now we have the integral of dx divided by sec of x multiplied by the square root of pi plus sine squared of x, and then the upper limit being pi, lower limit being pi over 2. Okay, remember the first thing first is to check if this thing is the inverse, right? So we need to make sure that if it's the inverse, we have we will make use of one of the formulas of the inverses. So I can see that, okay, the thing that is squared here, it's sine. So I can tell that that means on the numerator, I'm supposed to have the derivative of sine, which is cos. Okay, here I'm given sec, and I have 1 here on my numerator. So I'm gonna take that sec upwards. So now what I'm doing here, I'm rewriting this question nicely. So to do that, it involves me having to take sec up. So when you take this sec up, it lifts that 1 up. So at the end of the day, we're gonna have 1 over sec of x divided by, so we're gonna have 1 over sec of x like that, and then we have square root of, we rewrite everything in the form of a squared f of x squared, right? So let's write this pi. So this is going to be square root of pi, square root of pi. I'm rewriting everything in that format of what squared, you understand? So I have square root of pi squared plus sine of x squared, like this, and then I have my dx there. So what am I doing, or why did I do what I'm doing, is that I want to force this thing to be, or I'm trying to check if it could be one of the inverses. So when I check, okay, this format of having square root of this a squared plus f of x squared could be that one of hyperbolic sine inverse. So that means the chances are I might be dealing with hyperbolic sine inverse here. So before I fully conclude, I must make sure that the numerator is the derivative of the whatever thing that is squared here. So to do that, I must change this 1 over sec to its equivalence when it comes to reciprocals. So I'm gonna write my pi here, and then my pi over 2 right here. So 1 over sec of x is the same as cos of x, when it comes to reciprocals. So what are we gonna do here? We're gonna also just we're just gonna change it into that, and then whatever that's left there, I am not gonna do any damage to it. I've already done enough damage. So sine of x here, and then squared. Okay, and then here I have my dx. So what's happening here? The thing that is happening here is that we now have the derivative of whatever that is squared here, meaning that now we can fully conclude and say that, okay, the thing that was differentiated for us to get this whole fraction was inverse hyperbolic sine, you know. So that's what we're gonna do. So inverse hyperbolic sine, so it's the inverse hyperbolic sine. So inverse hyperbolic sine of what? Of my f of x being sine of x divided by a, our a being square root of pi, that's a pi there, it's a pi, sorry. And then we're not gonna write plus c because we're dealing with a definite integral, so we're gonna put our upper limit and lower limit just like that. So this is going to be like this. All right. now that we are we have found our answer, we just need to only substitute the upper limit and lower limit and then get our answer. Another thing, that since that we're dealing with a trigonometric function, you need to make sure that your calculator is in radians, because we're dealing with a trigonometric function. This sine of x is a trigonometric function. So if we are going to substitute pi and pi over 2, then we need to make sure that our calculator is in radians. So yeah, so now let's substitute our upper limits. So this is going to be inverse hyperbolic sine of what? Sine of pi divided by square root of pi minus, we substitute the lower limit, so it's going to be inverse hyperbolic sine of what? Of sine of pi over 2 divided by square root of pi. There are a lot of pi's involved, so you need to make sure on your calculator you don't make a mistake. So right now I'm gonna punch in my calculator. Please be patient with me. I will be punching these things. So yeah, hang in there. So sine pi shift pi over square root of shift pi, and then minus. Remember, for you to be able to punch inverse hyperbolic function, you need to press HYP there, just under x squared on your calculator. So yeah, that's how you will be able, that's how you're gonna punch it. So shift pi over 2 and then divided by square root of shift pi. And then another thing, make sure your calculator is in radians for you to be able to get the correct answer. So the correct answer for this is supposed to be negative 0,538. So you should have gotten the same thing, provided that it didn't make a mistake. So ta-da, that's the correct answer that you should have gotten. So this is the answer for that question. Make sense? Okay. It does make some sense. Okay. I hope you got it. Just 2 last questions, including this one. It's 2 last questions. So let's solve and then we finish. We check what's next. Whatever that is next, we check it after this one. So now we've got our integral of what? Integral of 1 divided by square root of 1 plus 4x squared and then dx there. So our upper limit being 4 over 3, lower limit being 0. So we need to first rewrite this question in that way of f of x squared, a squared, so that we can see that it fits into which inverse. So that's what we're gonna do. First thing first, 4 over 3, our upper limit, and then we have 1 here. We've got square root of what? Square root of 1 squared plus, so 4x squared, I'm gonna write it as 2x squared, and then I have my dx. So this denominator of having a squared plus f of x squared, it's that one of hyperbolic sine inverse. So, but before we conclude, we must make sure that on the numerator, we have the derivative of whatever that is squared here. You understand? So when we check the thing that is squared here, it's 2x. So when we differentiate 2x with respect to x, what do we get? We get a 2. So there I have a 1, so I'm going to cancel it out and write a 2. So since this 2 was not there, I need to also cancel it out to write 1 over 2 outside the integral. You understand? Then from there, I then do this. I then conclude, because of now I have the derivative of whatever that is squared, and I can see that this whole format is that one of inverse hyperbolic sine. Then I make a conclusion and also take whatever that's outside the integral to go with me to the answer, and then I answer this, that this format is that one of inverse hyperbolic sine. So it's going to be inverse hyperbolic sine of what? F of x is 2x, and then our a is 1, so it's more like just 2x, yeah. And then I put my limit being 4 over 3 and 0. Then I just substitute there. Then we're just gonna substitute to see what is happening. So we're just gonna substitute our limits there. We're gonna have 1 over 2 inverse hyperbolic sine of what? Of 2 multiplied by 4 over 3 minus 1 over 2 inverse hyperbolic sine of what? Of 2 multiplied by 0. So 2 multiplied by 0 is the same as 0. Then we find out what our answer is. So now back to punching on our calculator. 0.5 multiplied by inverse sine, which is number 4 there. So it's going to be multiplied by 2 multiplied by 4 over 3 minus 0.5 multiplied by inverse sine of 0. Then you use your calculator. You should be able to get like something like 0,854. So yeah, I've punched it on my calculator. I'm getting that. So you should have gotten the same thing. That's how you will get your answers. Okay. Last question yamafello, question yakwetelela is the last question. Okay, so this is what we're gonna do. We're gonna say so now okay, now we're integrating what? We're integrating 1 divided by the cos squared of x multiplied by the square root of 9 plus 4 tan squared of x. Okay, so what are we supposed to do first? The first thing first is to make sure that we test if this fraction could be one of the inverses. So to do that, we can say that, okay, already the thing that is squared there, it's a tan. So definitely we need to have sec squared there on the numerator. So to do that, we can see that, okay, we need to take this guy upwards there so that we can have the derivative of whatever that thing that we are squaring there. Okay, also we are rewriting this question in that format of having a squared f of x squared. So let's do that. So this is going to be pi over 4, and then we have our 0 there. So we're gonna take, since we're taking this cos squared of x upwards, so when we take it up, it's gonna lift this one up. So it's gonna be like 1 over cos squared of x, like this. You understand? And then divided by, and then on our numerator there, what are we gonna do? We're just gonna rewrite 9 as a squared. So this is gonna be the same as 3 squared, plus we rewrite 4 tan squared of that as f of x squared. So this is going to be 2 tan of x squared, like this, and then we put our dx here, of course. So now that we have our question in this format, we need to just check this format of having square root of a squared plus f of x squared fits into what when it comes to those formulas in our formula sheet. So we check that and find out that it fits into be a sine inverse, you know. But before we conclude, we need to make sure that on our numerator, we have the derivative of whatever that is squared here, you understand? So since we have 1 over cos squared of x, and we know that when we differentiate 2 tan x, what do we get? We get 2 sec squared, you understand? So we need to make sure that we have 2 sec squared there before we make any conclusion. So, but we are fortunate because we know that 1 over cos squared is the same as sec squared when it comes to reciprocals, you know. So we're only gonna do this for the following step. We're gonna write that pi over 4, and then our 0 here, and then we write our sec squared of x divided by square root of what? Divided by the square root of okay, 3 squared. We are not changing anything in the numerator, in the denominator I mean, then tan of x squared. So what are we doing here? I've changed 1 over cos squared of x to its equivalent when it comes to reciprocal. Why did I do that? Because I know that on my numerator, I'm supposed to have the derivative of this. So now I go back again. When I say that when I differentiate 2 tan x, I get what? 2 sec squared of x. So I don't have a 2 there, so meaning that this is partially the derivative of this. So let's complete it by correcting the coefficient there. So I must put a 2 and then cancel out that 2, of course, by writing 1 over 2 outside the integral there, so that the 2 and 2, they cancel out. All right, since the 2 and 2 can cancel out, then I can now just make use of them being not cancelled, because of if it's not cancelled, I fully have the derivative of whatever that is squared here, you understand? So then now we've already discussed that this one is going to be sine, hyperbolic sine inverse, right? So I can just then conclude that that one is going to be hyperbolic sine inverse. So I take whatever that's outside the integral with me to the answer. So we'll have 1 over 2 and then inverse hyperbolic sine of what? Of f of x being 2 tan of x. Tan of x divided by a, our a being 3 for that case, and then I put my limits. I say pi over 4, and then what? Also my 0 there as my lower limit. And then the thing to be aware of is that now you'll be punching this answer involved a trigonometric function, so you need to make sure that your calculator it's in radians when we punch our answers here. So now we're going to punch our answers in the calculator to substitute the limits. So this is going to be 1 over 2 inverse hyperbolic sine inverse hyperbolic sine of what? Inverse hyperbolic sine of 2 tan of pi over 4, tan pi over 4 divided by 3 minus 1 over 2 inverse hyperbolic sine of what? Of 2 tan of 0 divided by 3. And then you close, and then you try to find out from the calculator how much is it that you get. Okay, so tan of 0, we know that tan of 0 is 0, right? So meaning that here you don't have to stress yourself. You can just use a big 0. So 0.5 multiplied by sine inverse. So sine inverse of what? Of 2 tan of pi over 4. Tan of pi over 4, you close 3. So I'm busy punching in my calculator right now, so just be patient with me. I'll be right back. So yeah, I get 0.31. 0.31 as our answer. So this should be the answer that you also got during the process of you finding the answer. So yeah, that was it for this question, guys. Take care. I'll catch you on the next video. Bye bye.